In our in-depth look at these advanced combat aircraft, discover how China's J-35A compares with the US's F-35, from stealth technology to engine performance. In November 2024, the Zhuhai Air Show unveiled a lineup of advanced military technology, prominently featuring the J-35A, a new fifth-generation stealth fighter from China's Shenyang Aircraft Corporation. This event showcased a range of aircraft, drones, and munitions. It highlighted the significant advancements of the People's Liberation Army and PLA Air Force in modern air combat capabilities. Amidst various hardware, the J-35A stood out, drawing immediate comparisons to the American Lockheed Martin F-35 Lightning II, one of the most advanced and widely adopted fighters globally. Both aircraft represent the pinnacle of stealth technology and are designed to meet the rigorous demands of contemporary warfare. However, despite their apparent similarities in design and purpose, the J-35A and F-35 embody distinct strategic priorities and technological paths shaped by the unique defense needs of China and the United States. The J-35A, originating from the Shenyang Aircraft Corporation's FC-31 technology demonstrator, represents a significant evolution in Chinese military aviation technology. Initially conceptualized as a potential export without direct PLA support, the FC-31 underwent substantial modifications to meet the stringent requirements of modern air combat, showcasing its capabilities through various prototypes first flown in 2012 and 2016. By the mid to late 2010s, the design caught the PLA Navy's attention, which led to its development into a carrier-borne fifth-generation fighter, tentatively named the J-35. The first prototype, flown in October 2021, featured notable enhancements such as an enlarged folding wing, reinforced landing gear, and a catapult launch bar. These modifications, along with an enhanced dorsal fuselage hump and sophisticated sensor array, indicated a mature design aimed at carrier operations. In the past, the PLA Air Force showed interest in adapting this advanced platform for land-based operations. By 2023, emerging prototypes with adaptations such as a reduced wingspan pointed to specific modifications tailored to the PLA Air Force's operational needs. This version was officially designated as the J-35A during the Zhuhai Air Show 2024, coinciding with the PLA Air Force's 75th anniversary. The J-35A and its variants often draw comparisons to the United States F-35, reflecting shared design features typical of medium-sized, fifth-generation fighters, such as dual-side air intakes and similar wing and tail configurations. While these similarities have sparked discussions about potential espionage and technology transfer, particularly in the context of alleged Chinese cyber operations targeting F-35 data, the convergence seen in other contemporary fighters like the KF-21 and AMCA suggests that these design traits may be driven more by a pursuit of optimal aerodynamic and operational solutions than by direct copying. The J-35A is strategically positioned within the PLA Air Force as a versatile medium-weight complement to the heavier J-20, expanding China's fleet of fifth-generation fighters. This development strategy aligns with the varied operational requirements of the Chinese military, from achieving air superiority to conducting precise strike missions. The F-35 in its role continues to be a central asset for the US and its allies, providing a critical blend of stealth, advanced sensor integration, and multi-role capabilities. Furthermore, China's military advancements include the operation of another stealth fighter, the J-20 air superiority aircraft, and the ongoing development of the H-20 flying wing stealth bomber, as reported in a 2023 Pentagon document on China's military forces. Both the J-35A and the F-35 are engineered with an emphasis on low observable stealth technology, which is evident in their sleek and smooth airframes. These designs are crucial for minimizing radar cross-section and enhancing operational efficacy by staying undetected during missions. The aircraft feature streamlined surfaces and curvature that disrupt radar wave detection, a fundamental aspect for stealth operations. The J-35A and F-35 incorporate similar aerodynamic components like canards and vertical stabilizers arranged in a distinctive V-like structure. This setup not only aids in maintaining a stealth profile but also plays a critical role in reducing turbulence, further decreasing radar visibility. However, subtle differences in their designs underscore divergent engineering approaches. The J-35A's stabilizers are slightly wider and set at a different angle, potentially offering better aerodynamic performance tailored to the specific operational requirements of the Chinese military. This could influence the aircraft's agility and its radar cross-section. Conversely, the F-35 features more sharply angled stabilizers optimized for an enhanced stealth profile. This design choice reflects a deliberate focus on radar evasion, integral to the F-35's role in U.S. and Allied operations, ensuring superior performance even in challenging conditions. The cockpit design of both aircraft fuses functionality and advanced technology, designed to meet the rigors of modern air combat. Each cockpit has a rounded glass canopy, optimizing pilot visibility and situational awareness, crucial during high-speed, high-stress combat scenarios. The J-35A's cockpit is narrower with a simpler design and less curvature in the canopy glass, suggesting a focus on practicality and cost efficiency. However, this design could slightly elevate the radar cross-section, albeit still adhering to stealth norms. In contrast, the F-35's cockpit is more expansive, featuring a sophisticated rounded canopy with extensive glass coverage. Specialized coatings on the F-35's canopy enhance its stealth capabilities, significantly reducing its radar signature while prioritizing pilot comfort and visibility. The rear sections of the J-35A and F-35 showcase significant differences in design philosophy, particularly around the engine housings. The J-35A opts for a more enclosed engine design with fewer visible edges and a smoother outline around the exhaust, aimed at minimizing radar reflections, a crucial element in stealth technology. This design is likely optimized to meet the J-35A's unique performance specifications, possibly prioritizing operational flexibility in varied combat scenarios. In contrast, the F-35's exhaust system is more intricate, with defined features that reflect advanced American engineering practices aimed at maximizing stealth. The pronounced design and use of cutting-edge materials in the F-35's exhaust system illustrate a comprehensive approach to reducing its radar footprint, aligning with the aircraft's strategic role in achieving air superiority. The wing designs of the J-35A and F-35 further reflect their distinct tactical priorities. The J-35A features slightly more angular wings, designed to enhance maneuverability, a critical factor in dogfights and rapid tactical shifts. This design choice supports the J-35A's presumed role in regional dominance and quick response scenarios. The F-35, however, sports smoother, more contoured wings that align with its overarching stealth strategy. These wings are engineered to minimize radar reflections and maintain stability at high speeds, supporting the F-35's role in deep strike missions and sustained air operations over hostile territory. The design variations extend to both aircraft's air intakes and landing gear. The J-35A's air intakes are wider and more angular, possibly increasing engine airflow and improving performance, but at a potential cost to its stealth profile. Meanwhile, the F-35's air intakes are designed with stealth as a paramount consideration, featuring a rounded, smooth structure that enhances airflow while minimizing radar detection. The J-35A's landing gear is simpler and more robust, likely designed to endure diverse and potentially rugged operational environments. On the other hand, the F-35's landing gear is more complex, incorporating features that reduce radar cross-section and enhance the overall stealth profile, which is critical for operations in highly contested areas. The J-35A achieves a maximum speed of Mach 2, surpassing the F-35's top speed of Mach 1.6. This superior speed equips the J-35A with an advantage in fast-paced combat scenarios, particularly in intercepting high-speed targets, which is crucial for air superiority roles. The design supports quick maneuvers and rapid response, aligning with its intended use within the People's Liberation Army Air Force. Conversely, the F-35 excels in range and versatility, featuring a longer operational range of approximately 2,220 kilometers compared to the J-35A's 1,200 kilometers. This extended range makes the F-35 more suitable for long-range missions and deep strike capabilities. It reflects its role in projecting power over vast distances and supporting varied mission profiles from ground attack to reconnaissance. Originally thought to employ Russian RD-33 engines, the J-35A is likely to transition to using more advanced Chinese-developed WS-13E or WS-21 engines. Future models are expected to incorporate the WS-19 engines, enhancing their thrust and performance capabilities. Both aircraft can refuel in flight, significantly extending their operational reach and endurance. This allows for prolonged deployment in contested areas without ground support. The J-35A incorporates a suite of advanced Chinese-made avionics, including AESA radar, infrared search and track systems, and comprehensive electronic warfare capabilities. These systems enhance the aircraft's awareness of its surroundings, which is crucial for engaging multiple threats simultaneously and adapting to dynamic combat environments. The F-35 has the AN/APG-81 AESA radar, AN/AAQ-37 distributed aperture system, and AN/ASQ-239 electronic warfare suite, offering unmatched sensor fusion and situational awareness. This integration allows the F-35 to detect, track, and engage targets at considerable distances, even in highly contested environments. Both the J-35A and F-35 maintain their stealth profiles by carrying weapons internally. The J-35A can carry up to 7,000 kilograms of payload, while the F-35 has a slightly higher capacity of 8,160 kilograms. This internal carriage design is critical for maintaining a low radar cross-section during missions. The J-35A emphasizes speed and agility for regional operations, while the F-35 focuses on versatility, range, and global interoperability. These aircraft demonstrate the advanced state of modern air combat technologies and illustrate the critical role of securing intellectual property in maintaining national defense advantages. Frank Kendall, the Defense Acquisitions Chief in 2013, highlighted the compromise of unclassified F-35 data, despite the classified information remaining secure. This breach reportedly allowed competing powers, particularly highlighted in Pentagon reports linking the Chinese government and military, to advance their military technology programs. In 2014, a Los Angeles grand jury indicted Chinese national Su Bin for assisting PLA hackers in stealing over 630,000 files related to the F-35 and other critical U.S. aircraft from 2008 to 2014. Bin's role involved facilitating the translation and targeting of sensitive defense technology, underscoring the depth of espionage activities to undermine U.S. technological supremacy.